Hello viewers, today we will discuss about the addressing modes of 8086 microprocessor. Now first of all, let us see what is addressing mode. For any microprocessor, for an instruction, the most important part is the operand or the data which is specified for that instruction. Now the addressing mode is nothing but the way of defining the operand or the data for that particular instruction. Obviously, data can be defined in a number of ways, like the data or the operand may be the contents of the register, it may be the contents of memory location, it may be the contents of memory location whose address is defined some or another way. In some cases, the operand or the data is defined within the instruction. So now let us see, depending on the different types of methods in which the operand is defined for an instruction, how the addressing modes are classified for 8086 microprocessor. Now let us have general definition of the addressing mode, and then we will see the different addressing modes of 8086. An instruction performs specific operation on specified data or the operand. The way by which an operand is specified for an instruction is called the addressing mode. In 8086 microprocessor, there are in total 12 different types of addressing modes. They are listed as register addressing mode, immediate addressing mode, direct addressing mode, register indirect addressing mode, based addressing mode, indexed addressing mode, based indexed addressing mode, based indexed with displacement addressing mode, then intra segment direct addressing mode, then intra segment indirect addressing mode, then next is the inter segment direct addressing mode, and the last is the inter segment indirect addressing mode. Now as we have used 12 different types of addressing mode, each addressing mode has a different technique to define the operand for an instruction. Now let us discuss one by one all the addressing modes. First one is the register addressing mode. Now as the name suggests, register, it means the operand or the data defined in this type of addressing mode will be in general purpose register. In register addressing mode, the operand is placed in one of the 16-bit or the 8-bit general purpose registers. As we know, 8086 microprocessor can perform the operation on 8-bit operand as well as on 16-bit operand. Now the different examples for register addressing mode are, first is move AX, BX. Now in this instruction, the register which is defined first works as the destination, and the register which is defined later on works as the source register. Now the instruction move AX, BX, it has the addressing mode as the register because the operand lies in the register BX, and this operand will be copied to register AX. Now as we have used AX and BX, it means X is the representation for 16-bit operation. Whenever a X is used in the 8086 instruction, it means the operation will be performed on 16-bit operand. Similarly, another example for register addressing mode is add AL, BL. Now here AL and BL, these are the part of the 16-bit registers AX and BX. AL means only the 8-bit of the AX, that is the lower part of the AX. Similarly, BL means only 8 bits of BX, that is the lower part of the register BX. Here add AL comma BL means the contents of register AL and BL will be added and the result will be stored in AL. Again, the addressing mode is register because the operand lies within the registers. So, register addressing modes purely means the operand lies within the registers. Now, next we come to immediate addressing mode. In immediate addressing mode, operand is specified within the instruction itself. Now, within the instruction means the operand on which operation is to be done will be defined or will be given by the user in the instruction only. For example, there is an instruction say move AL comma 35H. Again, AL means the operation is to be done for 8 bit only, and the operation is that the data which is defined in the instruction is to be moved to register AL. So, obviously AL is a 8 bit register, the operand or the data defined in the instruction will be of 8 bit, that is 35H. Now, this instruction will move 35H into AL, hence the addressing mode for this instruction is immediate. Similarly, another instruction with immediate addressing mode is move BX comma 0300H. Here X is used with A, so it means that the operand or the data used in this instruction will be of 16 bit. Now, BX comma 0300H means this 16 bit data 0300H will be immediately moved into register BX. Now, BL will contain 00H and BH will contain 03H. This instruction has the addressing mode as immediate. Similarly, we can have more instructions like add AX comma 4300H. Here the contents of AX register will be added with immediate data 4300H and the result will be stored as the contents of AX. Again, the addressing mode is immediate as the operand is defined within the instruction. Next, we come to the direct addressing mode. In direct addressing mode, the operand's offset address is defined or given within the instruction. Direct addressing mode means the operand or the data on which the operation is to be done, its address will be defined in the instruction. Now, let us see few examples of a direct addressing mode. First one is add AL comma square bracket 0301. Now, AL means the operation will be done for 8 bit operand, and we have used 0301 and it is written within the square bracket. Now, square bracket represents that the operand is available at a memory location whose address is defined within the square bracket. Now, add AL comma square bracket 0301 means the contents of AL will be added with the contents of memory location 0301 and the result will be stored as the contents of AL. Here addressing mode is direct because the offset address from where the operand is to be taken is defined within the instruction. Now, let us see one more example. Add square bracket 0301 comma AX. Now, we have used AX here means the operand to be defined will be of 16 bit. In this instruction, the contents of AX register will be added with the contents of memory location 0301 and 0302. 8 bit data will be provided by the memory location 0301, it will be the lower byte, and 8 bit data will be provided by the memory location 0302, again 8 bit data, and 16 bit data will be provided by the contents of AX, and when the result is available, it will be again stored as the contents of 0301 and 0302. Now let us see register indirect addressing mode. In register indirect addressing mode, the operand's offset is placed in any one of the registers from BX, BP, SI or DI as specified in the instruction. Now, these BX, BP, SI or DI are nothing but the registers which will define the address or the offset address of the operand. Now, let us take an example. Move AX comma square bracket BX. Now, X means the operation is for 16 bit. Now, move AX comma square bracket BX means a data is to be copied into register AX, but that data is available in the memory whose address is defined by register BX. In this instruction, the offset address is defined by register BX. Now, let us assume that BX contents be 0301, then the contents of memory location 0301 is transferred to register AL and the contents of the memory location 0302 will be transferred to register AH. Now, let us summarize it. In register indirect addressing mode, the address of the operand will be defined indirectly by the register. Now, the next addressing mode is based addressing mode. In based addressing mode, the operand's offset is the sum of 8 bit or 16 bit displacement and the contents of base register BX or BP. BX is used for data segment and BP is used for stack segment. In summarize, we can say that in case of based addressing mode, the operand's address is defined by some base register. Now, let us see few examples of base addressing mode. Move AL comma square bracket BX plus 05H. Now, let the contents of BX be 0301H. Now, the offset address will be formed by adding the contents of BX with the 05 displacement. So, offset will be 0301 plus 05, that is equal to 0306H. Now, in this instruction, the contents of the memory location 0306 will be transferred to register AL. Again, AL means the operation is for 8 bit data only. Now, the next addressing mode is indexed addressing mode. In case of indexed addressing mode, the operand's offset address is the sum of contents of index register SI, that is source index register, or DI, that is destination index register, and an 8 bit or 16 bit displacement. In index addressing mode, we can say that the operand's address will be defined by one of the index register of 8086 microprocessor. Now, let us take some example for indexed addressing mode. Instruction is move AX comma square bracket SI plus 05H. Now, addition of 05H clearly means that the displacement is of 8 bit. Now, the offset address is calculated from where the data is to be transferred to AX with the help of SI register and 05H displacement. Whatever will be the contents of SI, a 05 displacement will be added to the contents of SI, and from that address the lower byte will be transferred to AL and the contents of next consecutive memory location will be transferred to register AH. Similarly, we can have an instruction move AX comma square bracket SI plus 1234H. Now, here the displacement is of 16 bit and the instruction will be having the operand from two consecutive locations in the memory whose address will be calculated by adding the contents of SI register and 1234H. Now after this we come to another addressing mode, that is based indexed addressing mode. In based indexed addressing mode, the operand's offset address is the sum of the contents of base register, may be BX or BP, and the index register, may be SI or DI. In base index addressing mode, the final address will be calculated by adding the contents of base register and the contents of index register. Now let us take some examples of base index addressing mode. The instruction is add AX comma square bracket BX plus SI. Here the offset address is calculated by adding the contents of BX and SI. After adding the contents of BX and SI, we get a offset address. Now the byte which is available at this offset will be added to contents of AL, and the byte available at next memory location will be added to contents of AH. The final result will be stored as the contents of AX. Similarly, another example of base index addressing mode is move CX comma square bracket BX plus SI. Again the offset address will be calculated by adding the contents of BX and SI. After obtaining this offset address, the contents of this address will be transferred to CL and the contents of next memory location will be transferred to CH. The next addressing mode is based indexed with displacement. Now as the name suggests, based indexed with displacement means we will calculate the final offset address by adding the contents of BX register with the contents of index register plus a 8-bit or a 16-bit displacement to it. In this type of addressing mode, the offset of operand is given by the sum of base register, say BX or BP, comma index register SI or DI with 8-bit or a 16-bit displacement. Now let us take the example of base indexed with the displacement addressing mode. Move AX comma square bracket BX plus SI plus 05H. Now this is clearly an example of 8-bit displacement. Now the offset address is calculated by adding the contents of BX register with contents of SI register and adding a 05H, that is a 8-bit displacement to it. Now the final offset which is calculated, its content will be treated as a lower byte and it will be transferred to AL register, and the contents of the next memory location will be transferred to AH register. Similarly, another example is move AX comma square bracket BX plus SI plus 1234H. Now it is clearly an example of a 16-bit displacement. Here the offset will be calculated by adding the contents of BX with contents of SI plus a 16-bit displacement, that is 1234H. Now the offset calculated, its data, that is a 8-bit data, is transferred to register AL and the contents of the next memory location will be transferred to register AH. Now we come to another category of addressing mode, that is intra-segment direct addressing mode. Now what do you mean by the term intra-segment? Intra-segment means within the segment, that is we are in the same segment. It is defined for only the branching instructions. In this type of addressing mode, the offset jump location lies within the same segment and is defined in the instruction itself. For example, we use the instruction say jump 100AH. This instruction will transfer the control to the offset address 1000AH in the same segment. Means we are working within the same segment, we are not going out of the segment. Now the another category is intra-segment indirect addressing mode. It is defined again for the branching instruction. In this type of addressing mode, the offset jump location lies within the same segment, but it is defined by some register, say BX or BP. Its example is jump square bracket BX. Now whenever this instruction is encountered, microprocessor will go to the BX, and whatever will the contents of BX will be treated as a jump offset address, but it will be within the same segment. The segment will not change. Now the next category of the addressing mode is inter-segment direct addressing mode. Now the inter-segment means we can move from one segment to another segment. It is defined again for the branching instructions. In this type of addressing mode, the offset jump location lies in the different segment, and it is defined in the instruction as segment colon offset address. Let us take one example. We have used the instruction jump 3000 colon 100AH. Now let us assume that we are currently working in the segment 2000. Now the instruction used is jump 3000 colon 100AH. As soon as this instruction is encountered, microprocessor decide to jump from the segment 2000 to segment 3000. Now in this segment 3000, again microprocessor will demand for the offset, that in this segment to which location it has to transfer the control. Now that address is again we have defined in the instruction, that is 100AH. So after the execution of this instruction, the microprocessor will be in another segment. Earlier it was in 2000H, now it is in the segment 3000H. This instruction transfer the control to offset address 100AH in the segment 3000H. Hence it is a inter-segment direct addressing mode. Now the last addressing mode for 8086 is inter-segment indirect addressing mode. Obviously inter-segment means the transfer of control is from one segment to another segment, but in another segment the offset address where the control is to be transferred will be now defined indirectly by some register. It is defined for branching instruction again. In this type of addressing mode, the offset jump location lies in the different segment, and it is defined in the instruction as segment colon square bracket and the register which will define the offset address. Let us take an example, jump 3000 colon square bracket BX. This instruction will transfer the control to the offset address defined by the register BX in the segment 3000H from the current segment. So this is all about the different addressing modes of 8086. So friends, in this program we have discussed about the different addressing modes of 8086 microprocessor. We have gone through the various methods by which the operand can be defined for an instruction. We have seen that operand can be contents of a register, operand can be defined by the user, operand can be the contents of the memory location which will be defined by some register, operand may be at the memory location whose contents is defined by the register by adding some displacement to the contents of that memory location. So I think you might have enjoyed this topic of addressing mode of 8086. Thank you.